Hello, and once again we're here to learn a little bit about forms of quadratic functions. In this case, we're going to learn something about vertex form. So remember we were talking about in the last video that in linear relationships we have slope-intercept form and we have standard form, and each one gives us different information and we can switch between the two. So in this case, we're going to be talking about a new form, and we're going to see what kind of information we can get off it. But we want to make sure that we always remember that every function just takes numbers and changes them into different numbers. An input number becomes an output number. And once you get a set of these, you can represent that set on a graph, which will allow you to pick off even more sets of input-outputs without having to do any more calculations. So that's kind of our motivation. So this input-output machine is a little bit different. What we do is we subtract 1 from it. It has multiple steps. So we subtract 1, then we multiply the result of that by itself, then we multiply that result by 2, and then we add 3 to it. So let's just try some input-outputs. Let's try minus 2. Okay, so we're going to subtract 1 from it. So that'll make minus 3. Then we're going to multiply by itself, which will give us 9. Then we're going to multiply that by minus 2, which will give us minus 18. And then we're going to add 3, which will make minus 15, which will be the number that shoots out the output. Okay, let's do another one. So our goal is to be able to create things, objects, functions, that will make it so that we don't have the need to do all of these computations in the future. So let's try minus 1. So minus 1, subtract 1 is minus 2. Multiply by itself makes 4. Multiply that by minus 2 makes minus 8. And add 3 makes minus 5. So minus 1 will make minus 5. And once again, we'll just erase these results and start over. This one's a little bit easier. We're going to use 0. So 0 would be minus 1. Multiply by itself is just 1. Multiply by minus 2 would make minus 2. Add 3 would be positive 1. Okay, so now we'll keep going. Let's use positive 1. So subtract 1 from 1 would make 0. Multiply by itself is 0. Multiply by negative 2 is 0. And add 3 is 3. So 1, 3. Another example. Okay, let's keep going. We'll do a couple more. So let's go to 2. Okay, so subtract 1, that would make 1. Multiply 1 by itself is 1. Multiply by minus 2 is minus 2. And add 3 is 1. And we'll do one more. We'll just go 3. That'll be it. That'll be our set of input-outputs that we use. So subtract 1 from 3, you get 2. Multiply by itself gives us 4. Multiply that by minus 2 gives us minus 8. And add 3 gives us minus 5. Now, hopefully what you're noticing here is that you have this input-output machine that is giving us a result like we saw before, where this number here, minus 5, is going up to 3 and then back down to minus 5. And that suggests that we have a pattern like we had with standard form. But let's double check. Okay, so we know how to check to see if something is going to be a quadratic function. So this is plus 6. This is plus 2. This is minus 2. And this is minus 4. Or sorry, minus 6. And now we're just going to check and see how the first differences change. To get the second differences, it goes down 4, down 4, and down 4. And these are all the same. So that means the second differences are equal. And if the second differences are equal, then that tells us that this is quadratic. Okay, and that's just a fancy word for a machine that has a step inside that multiplies by itself. If you have a step inside that multiplies by itself and nothing too complicated inside otherwise, then it's going to be quadratic in nature, and this kind of bears that out, this whole idea. So now we can summarize what happened inside here. We take a number, our input, we'll call it x, and we subtract 1. Then whatever we get is our result, and we square that. That means multiply by itself. So we've dealt with these two steps. Then we take that result and we multiply by -2. Okay, then we just add 3 on the end. And we have to tell it that that's our output. So this is a representation of this machine. And we know that this is a quadratic relationship. So when we graph this, the graphical representation of this machine will be a parabola. So likewise, I just translated this to our machine, and we're going to label our machine with this short form rather than writing out all of this stuff. Okay, this math is just a short form for all of this stuff. So we take our inputs and we plug them in. So I'm just going to do 1 here just to convince you that this gives the same result. We'll do 3. So for this particular input, we have y equals -2, 3 minus 1 squared plus 3, which is -2 times 2 squared plus 3, which is -2 times 4 plus 3, which is -8 plus 3, which is going to be -5. So an input of 3 results in an output of -5. So all of these can be thought of as input-output sets, which we oftentimes think of as points. But really all a point is an input-output set. So I just shrunk this down here so that I could see it. So we don't want to have to keep going. We don't want to have to make infinite amount of these input-output statements. We just want to build a corresponding graph, and then we can use that graph to read off other points. So let's put on these points, -1 and -5. So -1, and then 1, 2, 3, 4, 5. There's our first point. Then 0, 1. There's our second point. Then 1, 1, 2, 3. 1, 3. Then 2, 1. And then 3, -5. 1, 2, 3, 4, 5. Up and then down. Okay, label it with the summary of what this rule is. 2x minus 1 all squared plus 3. Now notice where the vertex is. This is at 1, 3. And let's take a look at the step pattern. The step pattern here says go right 1, down 2. So -2. And then it says go right 1, down 1, 2, 3, 4, 5, 6. Down 6. So our step pattern then corresponds to this too. Old step pattern for the base function is 1, 3, 5. New step pattern for one with an a value of 2 would be 2, 6, 10. This tells us it opens down. And we get this information as well. Looks like the vertex is at 1, 3. So if we look at a kind of a nicer graph of this that I made with Desmos, you'll notice again the vertex is at 1, 3. We have the y-intercept there, but it's not clear how we get the y-intercept yet. Remember, we got the y-intercept by knowing standard form. ax squared plus bx plus c. That was the y-intercept. Well, I don't see that over here. This is a different form, so we can't really pull the y-intercept off of there. But if we could change this into that, that would be a powerful tool. And again, we're going to do that eventually in the next unit. So don't worry so much about that right now. We just have to understand what each of the equations is telling us, each form. Okay? So some of the information it tells us is that we have a vertex at 1, 3, which you can read off from this point and that point. The other piece of information comes from this. We know it opens down. And the step pattern is 2, 6, 10, 14, and so on. Okay, let's take a look at this one then, using the information we just got. We've got vertex at -3, 1. we have a step pattern now that's a half, right? It's a half of the first step pattern. So the original step pattern, 1, 3, 5, new step pattern, 1/2, 1.5, and 2.5. That's just half, right? Multiplying everything by a half. Also, this is positive, so it opens up. Okay, so let's try this. So we put our vertex at -3, 1. So I'm going to use this as 1, just to spread the graph out a little bit. Okay, so -1, -2, -3, right there. And I'm going to go up 1. So it's going to be right there. This is 1. Again, let's just label this to make it clear. And we can just use the step pattern now. So I'm going to go right 1 up a half this time. So right 1 up a half would be right there. And then from there, I'm going to go right 1 up 1.5, which would be up to there. And then I have to go right 1 up 2.5. So up 2.5 would take me all the way up here. Right? 1, 2.5. Okay, and then I just mirror these points over here. And I draw a nice smooth curve as much as I can. And again, I'm helped a little bit by the fact that I spread my graph out. Oh, I missed horribly there. Let's try that again. I didn't hit those points as well that time. We'll call that good enough. It's hard to draw on this. And so what did this tell us? It told us that we have a vertex and the step pattern, and that's enough information to draw the whole graph. So vertex form, really powerful for making representations. It's a little bit of a harder machine to understand, though, because you have to subtract first and then square. But it's still an input machine, and it's represented with some square, right? Has a square, and you can represent the equation as a parabola. Okay, when you graph it. And when you graph it, the form of the equation, vertex form, allows us to read off the vertex, which is hk, whatever this number is, and this number. And the a tells us whether it opens up or down. And what the step pattern is, which will be whatever the value of a is, times 1, then a times 3, then a times 5. Now, the only thing to watch out for is oftentimes people make a mistake about the sign here. Because this is a negative, if you have a negative h, so say -3, where the vertex is at -3, a negative and a negative will make this a positive. And so watch out. If you have y equals x minus 3 squared plus 1, then the vertex would be at 3, 1, positive 3, 1, right? And if you had y equals x plus 3 squared plus 1, then the vertex would be at minus 3, 1. And that's the snag most people kind of make little mistakes on. So just to summarize one more time, vertex form is just another way of writing machines that have inputs times themselves somewhere embedded in them. When you make an equation in vertex form that summarizes these rules, then you get y equals a number times x minus a number all squared plus k. When you graph that, you get a parabola. The a value of that parabola, or of the equation, will tell you whether that parabola opens up or down. It will tell you the step pattern, which all you have to do is multiply a by the original step pattern of the base function, and h and k give you the vertex. And watch out again for the opposite sign situation.